looking for all of the factors of all of these numbers. We already started with 1 times 20, 2 times 10. Does 3 go into that?
No.
4?
Yes.
Yeah, and if those two numbers are right next to each other, you're done. 4 times 5, we are done. So this method takes a little bit longer, but it's a method that you need to know your factors. Now, are there any common? This is in common. What else is in common? The 2 is in common.
4.
The 4 is in common. And is that about it?
Yeah.
So what was the greatest common factor? Is the 4. I should put it down here. And this one's going to take me forever, so I don't want to do that one. We're going to do a couple of these that are relatively easy. So the number 3, 42. Start with 1. 1 times what?
42.
1 times 42. Does 3 go into that?
Yes.
Because of your rule of divisibility, 4 plus 2 is 6. So 3 will go into that. Now, if I don't know what it is, I'd have to divide it through and figure it out. Is it 14? Okay. It's going to be 14. Yeah, because 4 times 3 is 12, so I just divide it on the side. So that's going to be 3 and 14. Then I go to the 4. Will 4 go perfectly into that?
Yeah.
We're done with the number 2.
No, the 2, just 2 times something.
Oh, I absolutely skipped 2. So I don't know why I skipped over to 3. Maybe because I'm looking at that too. So you're right. 2 times 21. And then we just did the 3. 4 won't go into it because 40 is the closest number. The next one would be 44. 5, 6,
Yes.
6, and then 6 and 7 are close together, so you're done. And so 14 is going to be super easy. Tell me a pair starting with 1. 1 times 14, 2 times 7, and then I check these in between 3, 4, 5, nope, 6, that's it. So common factors are the 1, the 14, is the 2 in common, the 7 is in common, so 14 is in common in both of them. So all of those are common factors. Which one, however, is the greatest common factor? The 14. So that's that method. Now, I'm done with that method. I'm done. No, we're not doing any more of those. Okay. All right. So, okay. Sam, focus. All right. Now, I don't want to use a lot of time to do this, but it says find the greatest common factor using prime factorization. Did you do the factor trees last year?
Yeah.
Okay. I'm not fond of them. I think what I'll do is just do the ones down here because I don't want to make a big factor tree. So I'm going to start from here using the factor tree. Actually, I'm going to do it different. I'm not going to do a factor tree. Listen carefully. But you do need to know the prime factorization, which is the multiplication of the prime numbers. I don't like to use it to find the greatest common factor, but you can. So let's go ahead and look at this one, and I'm going to do, it's the same thing, almost the same thing as a factor tree, but it's neater and it's upside down division. So I'm going to do it with the 25. And I gave you paper. If you want to use paper, you can do it on paper. So I'll do this one, the number 11. So number 11, the 25. So I'm going to do an upside down division. Now, what you do with this, rather than a factor tree, it's a lot neater. You only divide by prime numbers other than 1. What's the first number that goes into 20? It's 5. 5 is the only number. 5 goes into 25, and you put your answer here, 5 times. Does anything else go into 5?
No.
No, done. We're done with that one. And then the other one is 50. Okay, so I have to use a prime number. So I'm going to use 5 again. Does 5 go into 50?
Yes.
So 5 goes into 50 10 times. Does anything else go into 10?
Yes.
2. I could have put 2 or a 5. It doesn't matter. Because if I put a 5 here, I would add a 2 here. If I put a 2 here, I would get 5. 2 goes into 10 5 times. So the prime, I'm going to write it out. Yes, sir.
Could you have that at 10?
No, because it's not prime. We want prime factorization. Now the factorization for this is 5 times 5. That is that's the multiplication of those prime numbers. In fact, I'll just write it right here. 5 times 5. Then this one is, we usually write it with the smaller number first. 2 times 5 times 5. And then you'll actually see it. Maybe I'll throw that in tomorrow where we do it. We'll do it again tomorrow where we put it in exponent. So that's as far. But how you get the greatest common factor in this case is there a 5 in common in each of them?
Yeah.
So I'm going to circle it. So there's a 5 in common. Is there anything else in common? Another 5. So I put them together. So the greatest common factor is what?
25.
Is 25. I only showed you this because we need to know how to write the factorization. And I will throw in something else probably tomorrow. But the greatest common factor, had I reduced that, would have been 25. And again, yesterday we just did it where it's 25 and 50. Can you see a number that, and when you do this method, you don't have to use a prime number, but you can. Who knows the number that goes into both? Well, 25. 25 goes to that once. 25 goes into that twice. Here's your reduced fraction. There is your greatest common factor. So I kind of like for 2 numbers, this is the quickest method. In fact, let's just do it that way on this one. Who can see a number that goes into these 2? 25. So 25. How many 25s are in 50?
2.
2. How many 25s, try to write it down, how many 25s are in 75?
3.
3. Is 2/3 reduced all the way?
Yes.
So my greatest common factor is what? The 25, the one on the left. So we're going to look at this one. I don't want to do the factorization method. I'm going to go ahead and do the one we did yesterday. Okay, so do this upside down. Can you see a number that goes into both 8 and 20? But if I'm going to do a smaller, only if some people didn't see it. I'm going to do 2. 2 into 8 goes how many times? 4. 2 goes into 20 how many times?
5. Wait, no, 10.
10. Now, does something else still go into 4 and 10?
Yes.
What number?
2.
So I'm going to divide by 2 again. So 2 goes into 4 2 times. 2 goes into 10 5. Is 2 over 5 reduced completely? Sam, focus. And that's reduced completely, so my greatest common factor in this case are both of these on the left when I do what to them?
Multiply.
When you multiply them. 2 times 2 is the 4. And so we're gonna skip, we're not gonna do all of these. In fact, let me look at our time because I gave you more than we possibly can do. This is gonna be 2, yeah. Which problem are you talking about? Oh, that's a good one.
That's number 1.
Yeah, what's the only thing that'll go into both of those?
1.
Is 1.
And itself.
And you get that same number again. So it is 1. In fact, let's just finish these up. What about the number 10? What's the only number that's going to go into those?
1. What?
A 1. Let's not be silly. Let's not be silly because your silliness can cost you being in this class. All right, so again, the greatest common factor is 1. Because if you're telling me 7, you don't need to be here. All right, then on this one.
Seven.
On this one, 7. And let's just double check it. 7 into that is 5. 7 into that is 4. If I had a fraction 5 over 4, it would be completely reduced. So our greatest common factor is 7. Right. And then we might as well go ahead and do this one. So let's start with 3 only because somebody said it, and then we'll see if we can reduce it more. So that's 9. 3 into that is 30. But can something still go into 9 and 30? 3. 3 into 9 is 3. 3 into 30 is 10. Is 3 over 10 completely reduced? Yes. So that tells us we're done here. Our grade are these two on the left, not that one. These two on the left. So what's our greatest common factor? 9. Had we used 9, we would have gotten to that directly. So that's 179, 179. We've got our 4 and our 2 1s. Alrighty, then don't have to do anything else. We're done with that. Alright. Okay, this one says greatest common factor.
15
Yeah, you will have some with 3. And I'm pretty sure, let me see, greatest common factor. We're not going to have time to finish all of it. All right, so let me think about this just for a second. Okay, I think this method works great if you have 2. I don't know if it works if you have 3, but I haven't tried it.
It's like the same thing, but with that.
Well, let's go ahead and maybe try it. So we can try it. So we'll try it. I absolutely know it does not work if you're finding least common multiple. So on this one, it's going to be, we'll do just the example 9, and I put them in order 24, 27, and I'll do the same thing. Because some people are doing the factor tree for all of it, and we can. If it doesn't work, we can do the factor tree. So what goes into all of them? 3. And so what's going to be left on this one is a 3. What's going to be left on this one is an 8. And this is going to be a 9. And it actually does work, because if I had a, I'll just do it real fast. You don't have to do it. If I had a factor 3, 3 times 3, 24 is 3 times 8, which that 8 is 2 times 4, 2 times 2. Again, you don't need to write this. This is 3 times 9 and 3 times 3. So 3 would be in common in all of them. And the only thing left is a 3. Is there a 3 in any of these?
Yes.
But is there a 3 in all of them?
Yes.
Is there another 3 in all of them?
Not all.
No, it has to be in all of them. It has to be common in every single one of them. So 3 is the one in common in all. So this is actually a better method for, rather than to do this, to do this.
So like even though the 3 and the 9 can be simplified because the 8 is there.
It's saying what's the biggest common factor. It's as if I had, we don't, but it's as if I had a triple fraction. We don't have triple fractions, but if I did, the only thing I could reduce it by is 3, 3, 3, 3 times 3, 3 times 8, 3 times 9, and that would be my new reduced fraction. I can't reduce it anymore by another number. Nothing else reduces all 3 of those. All of them have to be reduced by the same number. So you can use this shorter method using the upside. You cannot for least common multiples. So let's just go through some of these, and I'm going to only give you a few. I thought I was going to do the 2 pages, but there's no way.
Yeah, it's so long.
Okay, trust me, I'm not going to do it. Okay, so girls and boys. So you can do that method on, let's take one that's sort of big here. Let's look at this one. Oh, the 20 is a good one. Okay, so, and you will have to use your paper because there's no way. So on 20, okay, 20, I'm going to put the 48, the 60, and the 84. 48,
Sure.
60, and 84. Yes, sir. Yes, okay. Who thinks they know a number that goes into all of them? What do you think?
4.
Okay, we'll use 4. Okay, so 4. So Charlie, write it down because you didn't know how to do this yesterday. 4 goes into this. What? Well, ma'am, you can ask for it. Here, sweetie. In fact, I asked you if you had some. You said yes. All right, so this goes into that 12 times. 4 goes into 60. How many times? Is it 15? It is 15. because 15 and 15 is 30, and 2 more of them are 60.
Oh, yeah.
Okay, and then 4 goes into the 8. 4 goes into 8 2 times, and you're right, 4 goes into the 4 1 time. So now look at the numbers that are left. Can you see another number? 3. And I wouldn't look at this because that could be a 1 times 12, 2 times 6. I would look at one of these. There's only a 3 and a 5 in this. And so I would say, does 5 go into each? Nope. Does 3 go into each? Yes. So 3 will go into that. 3 goes into 12.
4 times.
4 times. 3 goes into 15.
5 times.
5.
And then 7.
3 goes to that 7. And if this were a triple fraction, 4, 5, 7, could 4, 5, 7 be reduced again?
No.
No. So our greatest common factor, who thinks they know what it is?
12.
12. It's these two that are on the left. Did I?
Is there really such thing as that? A triple fraction?
No. But I just show it some, no. But I just show it sometimes because it makes a little bit more sense if we're trying to reduce this. Okay, boys, I need you 3 to quiet down. Thank you. In this area. Just the 3 of you. All right, thank you for being quiet. All right, so here we go. So this one was 3. They already had that answer. This one is the 12. And find your answer and cross it off. The mixed-up answers are down here. So do you want to do one more of these?
Yes.
Okay, pick one out.
21.
18.
I think 21. Okay. So let's look at 21 and get the work down. So I usually put them in order: 42, 75. Again, the alternate is to do the factor tree on all of them. Do you like doing the factor tree on all of them? I don't. Okay, takes too much time. So let's find a number. And I'm going to say 3. Why did I say 3?
Because it is.
Well, because 7 and 5 adds up to 12. 3 will go into it. 3 goes into that. And 4 plus 2 is 3. Can you think of it? 6 won't go into that because it's not even.
No. 4 plus 2
Is 6. You're right. So I'm going to start with 3. I wish I could think of another one, but I can't. Okay, so 3 goes into that. Is that? I just have to divide it through because I don't know. That's going to be,
What, 14?
I think you're at 14. So 14. There's 3 of what coin and 75 cents?
25.
25. And there's 3 goes into that 9.
30.
So 30 times. And then let's look at what's left. The only factor of 25, it only has one set, is 5 times 5. Is there a 5 in each one of these? No. So if that were a triple fraction, it could not be reduced. So your greatest common factor is what?
3.
Is 3. Alrighty. And then you're going to go down here, and now you're going to apply your knowledge of the greatest common factor. And if you already know the greatest common factor, there's not a lot of work to show. In fact, on this one, use the greatest common factor. So I do want you to tell me what the greatest common factor is. Does 12 go into 24? Then you're done. So it's 12 times 1, and 12 times what will give you 24? Times 2. So I can cross out the greatest common factor, and that is the fraction in the simplest form. So is that answer down there, 1/2? It's right over here. And all of these are grouped together, so all of those are going to be there. Which let's look at the number 29. Looks like a good one. Okay. Okay, 29. Alrighty. So on this one, I'm going to maybe write number 29. You can write all of those like 39,104. Because there's only 2, you can write them like that. Now, who knows the only factors for 39? And if what's that?
Only factors for it?
Yeah, the only factors. What 2 numbers multiply to give you 39?
13 and 3.
3 times 13. So I'm going to see if 3 or 13 goes into this. I know 3 and 13 go into this. Does 3 go into this one?
No.
No, because 4 and 1 add up to 5. It would have to add up to 6 for 3 to go into it. So we're going to try the 13, and I'm just going to guesstimate 13 times. What's going to be something that gives me a 4, 8? 8 times 3 is 24, and that's it right there. So our greatest common was 13. 13 goes into that 3. 13 goes into that what? What did we just get? 8. So this tells me my reduced fraction, and this is my greatest common factor. So I'm going to show it just like that. I'm going to put 13 times 3, 13 times 8. So we're using our greatest common factor to reduce it out. Okay, did anybody miss how I got 13? Okay, so I just find like that only had 2 factors. This one has 2 and something else. A lot of things might go into this, but you look for the one that has the smallest amount of factors, and then which is 3 times 13, and then do either of those go into this? And sometimes you just have to test it out. So you're going to do, these are smaller, so I bet you can get those right away on most of those. Like this one, what's the only thing, what's the biggest thing that goes into this? 5. You got it right away. 5 times 3, 5 times 4. And again, you can always take those, like on 20, and you can list it like this, and get your reduced fraction on the bottom. Then, this one, it says write 2 equivalent fractions. We're not going to do that. You are just going to reduce. Okay, so it's basically the same thing. Which 2 look the hardest to reduce? There's 2 that are hard.
34.
34, good choice. And 36 or 33? 33 and 34? Okay, so let's write those down. Let's do 33, put 108 and 144. Okay. And start somewhere. Where do you want to start? What number? Say that again?
Or no, 144.
Yeah, but I can't divide by 144. Tell me a number that'll go into both of those.
2?
2, I'd start with 2.
I thought you were talking about what number.
Okay, so, and this is number what? I better number 33. Okay, so half of 108 is 54. Half of 144 is what? 70. 72. Okay. Okay, now it's a little bit smaller. Can you see a number that'll go into both of them?
82.
Actually, maybe 8.
Oh, wait.
Yeah, I think 8.
6.
No,
6.
9.
Oh, 9 goes into them. You know, 2 would have been fine, but then okay, I'm going to use 2 because nobody came up with it, but it is 9. Well, but even 9, I don't think it's going to reduce it all the way. We'll find out.
No.
Okay, I'll put 9. Okay, so 9, that's going to be what?
6.
Is going to be 6. 9 goes into that 6 times. 9 goes into 72, how many times? 8. Is 6/8 reduced all the way?
No.
Okay, so we can still divide it by what?
2.
By 2. 2 goes into that? 3 times. 2 goes into that? Is that reduced all the way?
Yeah.
So, I know my fraction is 3/4, but what is the greatest common factor? 9, yeah, 4 times 9 is 36. So it is 36. And by the way, watch how I do this real quick. 36, here's my 108, 36 times 3, this 36 times 3 is that 108, so it's times 3. And then 36 times 4 is going to give me that. That greatest common factor times 4 is the 144. And so it reduces down to 3/4.
Oh, that's put 2.
What's that? It says,
2 equivalent.
we're not going to do 2. We're just reducing it all the way down.
Oh.
We're just reducing it all the way down.
Forget everything and just circle the reduce.
And then find that answer. You have to show, again, show it with your greatest common factor and fraction, and I think that's over here. And then we'll do that number 34, because that's a big one. So again, I'm going to set it up 102 and 316. Can you see a number that goes into it?
No.
Two.
Maybe
2. Okay, so half of the 10 is 5. Half of the 2 is 1.
Wait.
Yes.
I was gonna say, doesn't 102 fit into 3?
Does 102 what?
Yeah, it's 316.
No, because 3 times that would be 306, not 316. All right, then 2 into this. I don't want to work too hard to take half of that. Half of 300 is 150. What's half of 16? So it's 158. Okay. Then, I know the factors of this are 3 and 17. How do I know that? Because I know it. 5 and 1 is 6, so 3 does go into it. Does 3 go into this? 8, 9, 10, 11, 12, 13, 14. 3 does not go into both of those.
I was saying that.
Okay, what?
I was saying that, like, doesn't like the 3, like,
3 goes into this one, but why doesn't it go into this one? It has to, remember, it has to add up to a number that 3 will go into it. So if I add 1 and 5 is 6, and 6 and 8 is 14. 3 won't go into 14, so 3 won't go into that. So the only other thing that I can try is 17, unless, oh, in fact, well, okay, the only other thing I'm gonna try is 17. I know 17 goes into that, and I'm gonna go 17, and I'm gonna ballpark it. I'm gonna say 9, which is, it's not gonna go. That's 63, that's 153. So in other words, it can't be reduced. The answer is going to be 51 over 158. So it's going to be 2 times 51, 2 times 158. So that is our reduced fraction. I hope. Is it down there? It's right here. And the other answers I think you can get because they're pretty small. So your job, people, and I might, because of time, I might pick up the 2 assignments tomorrow, is you're going to find your greatest common factor here and then reduce the rest of the fractions. And that is it. That one page. Just finish this page.
oh, well, I know, like.